Hi guys, yesterday we talked about direct and inverse variation. Today we're going to start talking about how to graph rational functions. And so before we get going with that, let's just make sure we understand what we mean whenever I say rational function. And you notice if I didn't highlight it enough, it's bolded, it's written in caps. The key thing here is ratio. And when we say ratio, okay, rational doesn't mean like logical, the logical function. In mathematics, a rational function is something that can be written as a fraction. A function that contains a fraction. Okay, so that's what we're going to be working with. Let me finish writing this. So rational really means fractional, okay? You're going to see all sorts of fractions in this unit, and I'll tell you what, this is like the number one missing skill of kids that go on to higher math. Those kids that come back and ask for help with calculus, they know how to do the calculus stuff. It's the simplifying fractions that gets them. They really struggle with working with fractions. So this is a unit you might find a little difficult, and that's okay. Understand, though, that it's something we got to work at to get better, you know. The parent function, that means the most basic function that we have that is a rational function, is going to be 1 over x, okay? Y is 1 over x. And so if I go through and I just make a quick little t-table, it's a pretty simple t-table. If I put 1 in for x and I'm 1 over 1, it gives me 1 for y. And if I put 2 in for x, that means I have 1 over 2, which is 1/2. And if I put 3, I'm going to get 1/3, and so on and so forth. And you're going to get something that looks kind of like this. 1/2, 1, 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9, and 1/10, so on and so forth. And vice versa. You know what? If I put in like a 1/2 then, that means I have 1 divided by 1/2, and if you put that in your calculator, you're going to see that actually gives you 2. And if I put 1/3 in, that's actually going to be 1 over 1/3, which is 3. 1/4 gives me a 4, so on and so forth, which is pretty interesting. I end up with something that looks like this: 1/2, 1/3, 1/4. And I get this cool little shape that looks like this. Okay? And so what you'll notice is there's really not a value, first of all, that I can put to make this a 0. Even if I put like a billion in for x, it's 1/1,000,000,000, and that's not 0. I mean, it's really tiny, but it's not 0. And even if I put in, well, here's an issue. What happens if I put in 0? I get 1 divided by 0. We don't know what that is. That's like infinity or something. So we can't even put a 0 in. And that brings us to one of the important ideas here, is that you can't divide by 0. That's going to be huge in this chapter. The nice thing is also, if I repeated this table and I put in a negative value, a -1 gives me a -1. -2 is -1/2. -3 is 1/3, so on and so forth. It just turns it negative, which means that instead of going up 1 over 1 to the right, I'm going to go left 1 down 1. And so I get this mirrored equation. And for the sake of time, I'm going to go ahead and just start to draw off the graph. But I get this mirrored equation, and it's going to end up looking something like this when I go and I graph it. Okay? And this shape is called a hyperbola. Okay? That is the shape that we're working with, not a parabola. Different, right? But it's a hyperbola is the shape that we're going to work with. Okay? You'll notice a couple of things. All right? First of all, there are asymptotes in this equation, and if you remember, it's a line that we approach but don't touch. A value that we approach but don't touch. Or I'll say don't reach, okay? A line we approach but we don't reach. And in this case, I see 2 of them here. See, there's a vertical one right here. There's a vertical asymptote right here. The line seems to approach x equals 0. But it never reaches 0. The reason is I can't put in 0 for an x coordinate, right? Can't put it in. I have 1 divided by 0, and that's an issue. But I also see that no matter what I put in for x values, okay, even if I put a billion and I have 1/1000th, okay, and that means that I'm never going to reach 0. And so I have a horizontal asymptote right here, a dotted line that we're going to draw on all of our graphs at y equals 0 for this parent function. Okay, so we call this then the vertical asymptote. That's because it's the vertical line that we approach but don't touch. And we're going to call y equals 0 the horizontal asymptote. So these are all things that you're going to see as we go through and we graph our problems in this unit. This shape is something you're going to become very familiar with. The vertical and horizontal asymptotes you're going to become very familiar with. And in the next video, I'm going to show you like the basic steps to graphing a function. So hopefully that gets you going, a little bit of definition, a little bit of work, and just seeing a picture of a graph and what we're going to be working with.